last class about what is a monomial, but let's just review quickly and just put this down in here. So a polynomial, poly means many, and it's a prefix that's used in lots of fields. Chemistry, polymer is like a type of, I don't really know what the chemical makeup is, but it means many. A polynomial is basically many monomials. It's the sum or difference of monomials. Whoops. I hope I'm not going to have problems with my board today. There we go. And a monomial is the product of numbers and variables. We're multiplying numbers and variables together. Right? So for example, 2x, negative 3a squared bc. Those will all be examples of monomials. A polynomial is when you add or subtract several of these together. And we also discussed what a like term is. When you have these several monomials added or subtracted together in a polynomial, we usually call each part of that a term. Each of those monomials is a term. So we did discuss also what it means to be a like term. Whoops. Does anyone remember what that means or can give me an example? Yeah. Yeah, so it's when two monomials or parts of a polynomial have the exact same variables and the exact same exponents on each variable. Okay, so for example, 2x squared and 3x squared are like, but 2x squared and 4x cubed are not. Okay, and the thing that we need to know about like terms is that if there are like terms within a polynomial, then we can simplify. We can collect those like terms by adding or subtracting coefficients. Okay, so we did quite a bit of review on this last week, so I'm going to move ahead. We also talked about this last week. How do we multiply numbers? And I just want to review this because this is going to come up quite a bit today in a model that we can use to actually multiply polynomials. It's not the only model that you can use, but it's one of them. Right? So I think I talked about you guys wanted to do 69 times 42, if memory serves me correctly. Right? We did that one. Yeah? And then we multiplied 2 times 9, and we got 18. So the 8 went there, and the 1 went there. And then 2 times 6 is 12, plus 1 is 13, right? And then you put a 0 down. And this is 4 times 9, which is 36. So that goes away. We cross out the 1. The 3 goes there. 4 times 6 is 24, plus 3 is 27. Is that right? All right, and then we can add. So that's 8, 9, 8, 2, right? This is an algorithm. An algorithm is in mathematics like a sequence of steps that you can follow every single time that get you the correct answer. But in my opinion, it's somewhat detached from what's actually happening between these numbers. Okay, so I showed you another model that you can use, which is essentially the area model, right? And so we draw a rectangle that has dimensions 42 by 69, but those are not very nice numbers to work with, and so we broke them up into the sum of two numbers that add to 42 and add to 69. And how did we break them up? 40 and 2 and 60 and 9. That's right, yeah. Because then we're just sort of dealing with essentially one-digit numbers, right? I mean, 40 is a two-digit number, but if you know how to multiply by 4, then you can multiply by 40 because you just multiply by 10 at the end. This is 60 and 9. Right? And then we can do, basically, instead of doing one multiplication, we do 4. And each of those 4 individual ones are much easier, right? So here's our 2 times 9. That's the 18. And that's the first thing that we did here. Right? And the 1 went over there because that represented not 1, but 10, because it was in the tens column. And then we went 2 times 6. So that's this piece here. It wasn't actually 2 times 6. It was 2 times 60. And that's 120, right? And we have that as 130, but that's because we took the 10 from the 18 and plopped it on there, right? And then we moved on and we put a 0 down because we're not actually multiplying by 4, we're multiplying by 40. 40 times 9 is 360. And then 40 times 60 is 2,400. Right? And then we can add all of these up together and we end up with the same answer, 2,898. Okay? So we can do this with numbers. The other thing that we could do with numbers, by the way, is we could do this. We can do the same sort of idea as breaking these up but into the sum of 2 numbers, but we don't actually have to use this area model. We can do this. 40 plus 2 times 60 plus 9. Okay? And then essentially what we need to do is distribute the multiplication of each one of these numbers into each one of these numbers. Okay? So I may start with the 40 and go 40 times 60, and I get 2,400. And then I have to add 40 times 9, and I get 360. And then I've done distributing the 40, so I can move on to the 2. 2 times 60 is 120. And then I can distribute the 2 into the 9 plus 18. You'll see all of these numbers are the same ones that appear in that rectangle. Okay, so that's another option. Now, of course, when we're working with numbers, we don't actually have to do any of these models. We could even just use a calculator to get the product, right? And so I'm sort of overcomplicating something that doesn't need to be complicated. But the reason that I'm doing that is that this is going to translate into what we're going to do with algebraic products when we're dealing with multiplying polynomials, in which case we're not going to be able to plug something into a calculator. Okay, so that's what we're going to talk about now. Okay, here's one example, expand and simplify. Okay, so when you are told to expand in math, that typically means remove the brackets. Okay, so we need to remove the brackets here by multiplying out. And then simplify means, in the case of polynomials, which is what we're going to get, collect like terms if there are any. Okay, now there's 2 ways that we can do this. Some of you guys may have seen the second way, which is the distributive property. I want to talk about using a rectangle diagram first, though. So we can do a similar sort of model that we did with the 2 numbers, 69 times 42, with these 2 polynomials. Now, when we had a 2-digit number, I broke the rectangle, each side of the rectangle, up into 2 parts, right? So the 40 was 40 plus 2, 60 was 60 plus 9. When I have a binomial, I'm also going to break that side length into 2 parts, one for the x term and one for the number. And this is a binomial by a binomial. So in fact, I'm going to break both sides, right, the length and the width, into 2 parts. And of course, it looks like each of these are equivalent. And of course, they're not, but this is just sort of a model that we're going to use to help us. And in fact, you know what? After we do this, I'm going to show you what this would look like with algebra tiles as well. So let's just start with this, though. So we've got x minus 4 and x plus 2. Okay, so each term in each factor gets its own section along either the top or the side. Okay, and then what I'm going to do is I'm going to multiply these 2 guys together to get the product, which is going to go in there. So x times x squared, yeah. X times negative 4 minus 4x. And then 2 times x, 2x. And 2 times negative 4, negative 8, right? Now, when you use this type of model, typically, not always, but typically, the like terms will line up along the diagonal. So I know here I've got 3 terms. I've got the x squared term, the x term, and the negative 8. Okay. Now, this is not an answer because we still need to simplify. So my final answer is going to be x squared, and then 2x minus 4x is minus 2x minus 8. Okay, now using the distributive property, I'm essentially going to do the same thing that I did when I had the 40 plus 2 in brackets times the 60 plus 9. X minus 4 times x plus 2. Okay, and each term in the first bracket one by one and multiply it by each term in the second bracket. Okay, so I'm going to start with this x and distribute that multiplication. So I'm going to go x times x, and I get x squared. And then x times 2, and I get plus 2x. Okay, so I'm done with the first term. I've multiplied that all out. Now I'm going to move on to the second one. I'm going to go negative 4 times x is, sorry, not plus, minus 4x. And then negative 4 times 2 is minus 8. Okay, so all together, when I collect like terms, x squared minus 2x minus 8. How many people have seen this sort of distribution before? Okay, cool. It's not actually part of the grade 9 program of studies. It's not on the grade 9 curriculum, but I know a lot of teachers do go over something like this. What is in the grade 9 curriculum is taking a monomial and multiplying it by a polynomial. But you don't actually have to have a poly times a poly, like a binomial times a binomial in that. It's not something that's required to teach. I know a lot of teachers do though, so I'm not surprised some of you guys have seen it before. Okay, what I also want to show you, we're not going to spend a ton of time doing this, but I just want to show you what this would look like with Algebra Tiles. Okay, so actually I'm going to add a page. If I was doing this with Algebra Tiles, in Algebra Tiles I have a bunch of them here. So if you ever want to play around with these, and we may actually do an activity, I think we will do an activity when we go in the opposite direction, when we factor, where we play around with these things. But essentially what we're doing is we're taking x minus 4 times x plus 2, or maybe it was the reverse. Okay, so what I'm going to do is I'm going to take one side that's x minus 4. If you've ever seen these before, how many have seen these things before? How many people have never seen them before? Oh, wow, that's awesome. Oh, okay, that's okay. So it's basically a visual model of how this could look. Okay, so the idea is that there's 3 different tiles, and each tile has a different color. It's either green or white, or the little ones are green and red. Okay, so the X tile looks like that. That's an X. Okay. Negative X, by the way, would be the white one. So you guys can see that over here. The white one is negative X. Positive one is the green one. Okay. And then minus 4, I need some of the ones. So the ones are the little guys that look like this. Okay, and if they're colored, if they're red, then they are positive, and if they're white, they're negative. So in this case, I want the negative ones, right? I want these guys, and I need 4 of them. One, oh, let me just, no. Hold on a sec. No, I need the mouse. Okay, so there's 1, 2. I'll line them up in a minute. 3 and 4. Okay. There we go. 1, 2, 3, 4. Okay, so that's the x minus 4 side. And then I've got the x plus 2 side, so I'll take another x out here. Now I'm going to turn this guy. Come on. There we go. And I'll stick it over here. So there's x and then plus 2. So I need the red guys. 1, 2. I'll take them out and then I'll line them up. Oh, for crying out loud. There we go. That's better. Okay. And this makes the side lengths of the rectangle that I'm going to fill in. And now what I will do is I'll take out my pen and I'm just going to essentially draw in lines to fill in this rectangle. The rectangle, the outside of it is going to be this whole thing. Okay, and then what we have to do is put the tiles that fit in there. The area is our product. So we can see in here, there's going to be one of the big tiles, and the big tiles either represent x squared or negative x squared. Okay. In this case, it's going to be positive x squared because x times x is positive, right? So I'm going to take this guy and I'm going to stick it in there. Oh, I need my, there we go. There we go. And then here I need to put some x tiles. Are they going to be positive or negative? Negative, because I've got positive x here times negative 1 here. Okay, so I'm going to take my negative 1s. I'm going to have to take out 4 and then turn them. It's a bit lengthy, this process. That's okay. Good to see at least a couple times. And then these can just slide in here. 1, 2, 3, and 4. Okay, and then of course, here we've got these also x tiles have to go in here, but this time they're positive because I'm going positive x here times positive 1. So I'm going to grab some of those. Those are over here and stick them in. There's 1 and there's 2. Here we go. So those go in there. And then what has to go in here? Looks like little 1s go in there, but are they going to be positive or negative? Negative, because I have positive here times negative here. So I think what I'll do actually is just take out 1 and clone it, because otherwise it's going to take forever. There we go. Okay, so I can go 1, 2, 3, 4, 5, 6, 7, 8. Okay. So when we made that little 2x2 box, this is actually what's going on, right? They're not all the same size, but they kind of divided into 4 sections, and the sections look like this, right? So here's one section. Oh, it's not going to let me just change colors. Maybe this will be better. That's very thick. Oh, wow. Here's another section, 2, 3, and 4. Okay? And so that's why we can simplify this by just making it a 2x2 box. Okay? And then, of course, what happens when you have like an x tile and a negative x tile? They cancel. Yeah, they make 0. It's actually called a 0 pair if you've ever worked with these before. So if you have 2 of the same tile but they have different colors, that's going to add to 0. Like positive 1 and negative 1 adds to 0. Okay? So this is not the last time that we'll see these. I think we're going to come back to them when we factor, but it'll probably be the last time today that we'll see these, because as you can imagine, this is a really good tool to be able to understand what's going on between the variables and to be able to understand the process, but it's not very efficient. It takes a long time. Okay? All right, let's try a couple more of these. Then I'm going to get you guys to try some yourself. So here we have, again, a binomial times a binomial. So if I'm going to use the area model or the box model, each side has to be 2 by 2, right? One section for each term. And here I've got 8 minus b and 3 minus b. And then I'm going to fill in the products, these are like partial products, into each of these 4 little squares. Okay, so 3 times 8, 24. 3 times negative b, minus 3b. 8 times negative b, negative 8b. And negative b times negative b, positive b squared. Yeah, so really important that you pay attention to the signs. Okay, now again, the like terms sort of lined up along the diagonals, so that's kind of nice. So I've got the 24, I've got this, the b terms, and the b squared. So all together, that is 24. Negative 3 minus 8 is minus 11b plus b squared. Okay, and then if you wanted to, you could rearrange the order of the terms here. You don't have to. Typically, though, when you're working with polynomials, we tend to arrange the terms in descending or descending powers, right? So this is the squared term. This is the b term. And then this is the constant. Okay, those are the same thing because the sign in front of each piece is the same. All right, now using distribution. Okay, of course, we're just going to do the same sort of 8 times 3 is 24. How many people have heard of the acronym FOIL? Has anyone heard that? Yeah? It's not, I don't love it. I'll tell you why. No. 8 times negative b is minus 8b. Negative b times 3 is minus 3b. And negative b times negative b is plus b squared. Okay? So FOIL stands for first, outside, inside, last. FOIL. I don't love it because A, it doesn't actually have to be done in that order. And B, it only works for a binomial times a binomial. And very quickly today, we're going to move beyond that to trinomial times trinomial sort of thing. Right? And then basically, FOIL, the acronym just doesn't work. You have to understand what it means to distribute, the distributive property. Okay? But if you want to remember it and it works for you for binomial times binomial, then that's fine. Okay? Now this guy. So negative 2g plus 8 times 7 minus 3g. If we set up a box, again, it'll be 2 by 2. Okay. Now I can tell you something. The like terms are not going to line up along the diagonal here. Does anyone know why? Just before we even start? Yeah?
Because the coefficient and variable is in the second place in the...
Yeah, because in each of the factors, the variable term and the coefficient have kind of swapped places, right? That's okay. You can still, if you wanted to reorder this, you could and make it 3g plus, or negative 3g rather, plus 7, that's fine. We can still work with it within this box as long as you know how to recognize like terms, right? So negative 2g times 7 is negative 14g. Negative 2g times negative 3g is 6g squared. 7 times 8 is 56. And 8 times negative 3 is negative 24, negative 24g. Actually, they did sort of line up along the opposite diagonal, I suppose. Okay, so this all together is 6g squared. Negative 14 minus 24 is negative 38g plus 56. Okay. I think just to save some time, I'm going to get you guys to try some of these yourself right now. So what I want you to do is I want you to practice using both strategies. Okay? Practice 2 of them, whichever 2 you want, using the distributive property, and then do 2 of them using that sort of box area model. Okay? So we can actually use both strategies to do this. We can use distribution, or we can use this box method. If we were to use a box, what would the dimensions of the box have to be? 2 by 3, right, because this is 2 terms, this is 3 terms. Okay, so I'm going to set that out for myself. Right, and along here, this is the 2-term piece, 2h plus 5. And then along here, I'm going to have h squared plus 3h minus 4. Okay? And then I can just go along and put these individual products into each of the little squares. So h squared times 2h is what? 2h. 1, 2, 3, yeah, cubed. Right? Because remember, this has a little 1 on it. So here it's like a product rule with exponents. We're adding the exponents. 2h times 3h. 6h squared. Okay. 2h times negative 4. Minus 8h. Good. Okay, and now I'm going to move on to the 5. So h squared times 5. 5h squared. 3h times 5. 15h, and 5 times negative 4 is minus 20, okay? And now, although this is not a square, there are like terms again along the diagonal. So I've got this, 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 and this. Okay, so all together, when I simplify, because this is not an answer, right? This is just a graphic organizer that essentially helps us to get this product. This is 2h cubed, and then 5 plus 6 is plus 11h squared. 15 minus 8 is plus 7h, and then minus 20. Okay, now if you use distribution, no problem, we can do that too. Okay, but now when I take each term in here, I have to distribute it to 3 terms in the other bracket, right? So I'm going to go 2h times h squared is 2h cubed. 2h times 3h is plus 6h squared. 2h times negative 4 is minus 8h. And then I'm done distributing the 2h, so I can move on to the 5. 5 times h squared is plus 5h squared. 5 times 3h is plus 15h, and then 5 times negative 4 is minus 20, okay? Now we again have to collect like terms. And the nice thing when you do it in the box is that they line up on these sort of backwards diagonals, but here you kind of have to search for them, right? So you've got an h cubed term. These are our h squared terms. These are our h terms. And then here's the number. So I'm just sort of like putting symbols under each of the different terms, and then we can collect them. So again, you're going to get the same answer. 2h cubed plus 6 plus 5 is 11h squared. Negative 8 plus 15 is plus 7h, and then minus 20. Yeah?
So you distribute like the first set, right? Like you don't do the rest of it?
You have, yeah, so you're going to distribute this into each of these. You could do it the reverse way. You could take each term in here and multiply it by these two terms in the first bracket. That's fine. Altogether, though, you're going to do 6 different little products, right? Because if you take the first 2 terms and multiply by each in here, you have 3 for this one and 3 for this one. And if you do it the other way, you're going to have 2 for this, 2 for this, 2 for this, so 6 in total. What's that? No, yeah, yeah. Exactly, and that's because like 2 times 3 is the same as 3 times 2, right? You can do it in any order for multiplication. Okay? All right, here we have a trinomial times a trinomial. So personally, I use the box method for this. I don't typically use it for binomial times binomial, and I don't typically use it for binomial times trinomial. But I will use it for something like this. And honestly, that's just because I've had a lot of practice, right? So even a binomial times a trinomial, I can do a lot of that in my head, right, without making mistakes. But for this, I just find it easy. It's more organized for me if I just set this up using the box, okay? So that's what I'm going to do. What would the dimensions of this one have to be? 3 by 3, that's right. Okay, so 3 by 3. And along one side, I'm going to have negative 3f squared plus 3f minus 2. And along here, I'm going to have 4f squared minus f minus 6. Okay? And then we can go ahead and fill in each of these little squares, right? So negative 3f squared times 4f squared. What will that be? Negative 12f to the 4, exactly. Good, okay? So if you didn't sort of master your product rule in the last unit, you're going to get it this time because we're going to use it a lot, right? So I multiply the negative 3 by the 4, and then f squared times f squared is f to the 4 because we can add these two exponents, okay? Negative 3f squared times negative f. Yes? Almost. Nope. Positive, yeah, because negative times negative is positive. So this is 3f cubed. And then negative 3f squared times negative 6? Yes, 18f squared. Okay? Now we're going to move down here. So 4f squared times 3f, 12f cubed. Okay? 3f times negative f. Yep. Right. Negative 3f squared, and then 3f times negative 6, negative 18f, right? Because there's just one of them, right? Okay, and then finally, negative 2 times 4f squared, negative 8f squared, negative 2 times negative 2, sorry, negative 2 times negative f, 2f, positive 2f, and then negative 2 times negative 6, 12, right? Okay, and then again, here we go. Okay, so simplified, this is going to be negative 12, thinner, negative 12 f to the 4, and then 12 plus 3 is plus 15f cubed. Okay, so negative 8 minus 3 is negative 11, plus 18 is 7, right? So that's what's also nice. Like you can just say, okay, there's all my like terms. So negative 11 plus 18 is 7 f squared. And then negative 18 plus 2 is minus 16f, and then plus 12. Okay. Now, while we are just on this note, actually, I wanted to mention one thing that I think I forgot to mention in the review, and that is the degree of a polynomial. Have you guys heard of that before? Yeah? Okay. What would the degree of this polynomial be? Yep. It's 4. Yeah. What's the degree of this polynomial? 3. Okay? And if we go to the other page, what would the degree of, like, this polynomial be over here? 2, yeah. So how do you tell what the degree is? It's not quite the highest exponent, almost. In this case it is, but what if I had something like this? What would the degree of this be? Yes, it's 6. Okay, the degree is essentially of all the terms, which one has the most variables multiplied together, right? And so this one has 5 a's multiplied together. A times A times A times A times A, 5, right? This has 4 a's and 2 b's. So in fact, the degree is 6. Okay? And we don't add the different degrees of each term. It's just the highest out of all of the different terms. Okay? So that's just one thing that I probably should have mentioned in our little review last week. But yeah, the idea of degree. Okay? All right, so thanks for following me on that little tangent. I would like you guys to practice. Actually, let's just do this one first, and then I'll get you to practice a bunch of them. Okay? Negative r minus 5t squared. Okay, so I'll tell you what I see a lot when we're looking at, and in fact I already saw someone kind of skip ahead in the homework and do this. Okay, and that's a really common mistake. And this is the same sort of idea, except we've got like 2 different variables and we've got coefficients on each variable. Okay? Now, we need to see why this is wrong. It's really tempting to do this. You just square the x and you square the 3 and there's a minus sign in between. Okay? Here's the problem. Okay? This cannot be distributed into here. What does this square mean? Yeah, multiply by itself, right? So this is actually wrong because this means x minus 3 times x minus 3. Now we need to make like either a 2 by 2 box or do distribution, right? So in a 2 by 2 box, x squared minus 3x minus another 3x, and then negative 3 times negative 3 is plus 9. Okay, so this is actually x squared minus 6x plus 9. Really common mistake. Okay, but just remember the square applies to the bracket. So when you're doing something like this, you have to take that and multiply it by itself. Okay, now if you want, you can make a box. I think I'm going to maybe do this one because we've done a lot of boxes using distribution. And when we distribute, and by the way, I do have a reason for going to distribution. If you want to use a box to expand every single time, that's fine. I don't have a problem with that. The reason why I'm pushing a little bit towards distribution is that we're actually going to spend most of this unit going in the opposite direction. Taking something like this, x squared minus 6x plus 9, and breaking it down into these 2 factors. Okay? Now you can do that by essentially undoing distribution or by using a box, but I find that if you can nail the undoing distribution down, then it's going to be more efficient. Okay, so that's why box is great. Use it to get a hand of how things are going and consistently get the right answer. But after a while, you should be able to move towards distribution, especially when you're expanding. Okay, so 2r times 2r, 4r squared. 2r times negative 5t. Yep.
Negative
Good. Negative 5 times 2r. Yes, negative 10 RT. You could write that as TR as well, but remember RT and TR are the same term because they have the same variables and the same exponents on each term. And then negative 5t times negative 5t plus 25t squared. Okay, so this becomes 4r squared minus 20RT plus 25t squared. And basically, once you take this and write it like that, it's just like all the other questions. Okay? So what I'd like you guys to work on for the next little while is to, sorry, not those ones, practice these ones up here, these two, and then also go to the next page and try this one over here. Okay? To keep in mind is order of operations, all right? Because this is going to take several steps. So we have to think about what are the operations that are happening between these different polynomials, and then how are we going to plan this out so that we can do things in the correct order, right? So when we look here, what is going on between the negative 2c minus, or the 2c minus 3 and the c plus 5? What math operation? Between this guy and this guy, what math operation's happening? Which is add, subtract, multiply, divide. Multiply. So this is multiply. Okay? What's happening here? Addition. What's happening here between the 3 and the c minus 3? Multiply. And here? Multiply. Okay, what's the last thing that we need to do? The adding. Yeah. So we're going to need to multiply these two polynomials. We're going to need to multiply these two polynomials and a 3. We'll talk about that in a sec. And then at the end of the day, we're going to have to add everything together. Okay? Now, this guy, and I might even do this off to the side. So if I have 2c minus 3 times c plus 5. Okay, how many people want to use box or distribution? I don't know. What do you want to do? Box? Okay. So I'm going to multiply those out. Right? 2c minus 3, c plus 5, and I get 2c squared plus 10c minus 3c minus 15. Okay, so all together this piece is 2c squared plus 7c minus 15. Okay, now, over here I'm multiplying 3 things together. So I was asking some guys back there, what's 2 times 3 times 5? 30, yes. Okay, good. So we know how to do this with numbers. When we're working with numbers, we do 2 times 3 times 5. We multiply 2 of them together first and get an answer. So in your head, you're going 2 times 3 is 6. 6 times 5 is 30. Or you could do it another way. You could go 3 times 5 is 15, then I multiply it by the 2 to get 30. But however way you do it, you'd multiply 2 of them together first, get that product, then multiply by the third. That's what we have to do here. We have to take any 2 of these, multiply them together, then multiply by the third. Okay? So just because they're in order, I'm just going to multiply this guy in. So this is going to become 3c minus 9 times negative 3c plus 1. Okay? I'll use distribution there, and then I can do my box, again, off to the side, right? So if I'm doing 3c minus 9 and negative 3c plus 1. Okay? So that's negative 3c times 3c is negative 9c squared. 3c times 1 is 3c. Negative 3c times negative 9 is 27c. And negative 9 times 1 is minus 9. Okay? One mistake that I often see is people want to take this 3 and multiply it by both of them first, and then multiply those two together. If you do that, you're actually multiplying by 9, not by 3, because you've got one factor of 3 in here and another factor of 3 here. Okay? So don't do that. Multiply 2 of them together first, then multiply by the third. Okay? Now we can do this addition. So if we take our first product, which is 2c squared plus 7c minus 15, and we add this guy, negative 9c squared. Oh, 3 plus 27 is plus 30c, and then minus 9. Okay. Now I have these in brackets just to show that I have two distinct polynomials that I'm adding together. But because this is addition, these brackets are sort of irrelevant, right? So I can just look at my like terms and say, okay, here's my c squared term, here's my c term, and here's my number, my constant, and combine those. Okay, so that's going to give me 2c squared minus 9c squared is negative 7c squared. And then 7 plus 30 is plus 37c. And negative 15 minus 9 is minus 24. Okay? All right. So I think we'll do this last one, and then I'm going to get you guys to try a couple yourself, and then we'll finish this off tomorrow. Okay? Again, here we have to think about order of operations. Okay, so what's happening here? There's a bracket. What's happening here? Multiplication, right? And I know when you're thinking about BEDMAS, we always think about brackets. How many people have heard it of PEDMAS with a P? Were you guys in French immersion by any chance? Yeah? Okay. Because so P is for parentheses, right? Yeah, so you may have heard PEDMAS or BEDMAS, parentheses, bracket, same thing, okay? So here's multiplication. Ordinarily, I would say do something in the brackets first, but the brackets are already simplified, right? There's no like terms in there, so we can't collect anything together. There's nothing to do in the brackets. Okay, the brackets really are just there to show what each polynomial factor is, okay? That's multiplication. What's happening here? Subtraction. And then here? Exponents, yes. So we do actually have to deal with that first. But what we're going to do with the exponent, guys, is we're just going to turn it into multiplication, right? So to deal with this, I'm going to get rid of that and then just go like this, times 3x plus 2y, right? Because if I square something, I multiply it by itself. Okay? So now I have turned this guy into multiplication as well. And now I know, okay, the subtraction has to come last. So I need to do each of the multiplications first, and then I'll do the subtraction at the end. Okay? And you may want to do that off to the side. Over here, this is going to be 3 by 2, or 2 by 3, if you make a box. Right? Oh, whoops. So this is 3x plus y minus 1, 2x minus 4. Right? So we're going to have 2x times 2x, 6x squared. 3x times negative 4 is minus 12x. 2x times y is just 2xy. Y times negative 4 is minus 4y. And then negative 1 times 2x is negative 2x, rather. Negative 1 times negative 4 is 4. Okay? Our other polynomial product, we're multiplying these two together, was the 3x plus 2y. That was it, right? 3x plus 2y times 3x plus 2y. Okay, so here I'm going to have 3x times 3x, 9x squared. 3 times 2 is 6, so 6xy. This is, again, 6xy. And then 2y times 2y is 4y squared. Okay, so what I need to do is take the first guy and subtract the second. And I'm going to kind of do 2 steps in one. I'll put that subtraction down as I combine like terms within this box. Okay, so I've got 6x squared. And then I do have another x term. There's the negative 12x and the minus 2x. So that's going to be minus 14x. And then 2xy, that's the only one of those. So plus 2xy minus 4y plus 4. That's the first one. And then I have to subtract the second one. So minus 9x squared. 6xy plus 6xy is plus 12xy. And plus 4y squared. Okay, now this is really important, and it's a big distinction compared to the last one that we did. We are subtracting polynomials here. We're not adding them. So this subtraction over here applies to everything inside this second bracket. It applies to the entire polynomial. So take the extra step of distributing this subtraction into all of these terms. Okay. Nothing happens here because there's just a positive sign outside. So this is going to become 6x squared minus 14x plus 2xy minus 4y plus 4. But then I'm going to have minus 9x squared minus 12xy and minus 4y squared. Yes, I saw there was a question at the back. Yep. Okay. Right? And now I can combine the like terms. And I believe there's only a couple. There's the x squared term and there's the xy term that are like. And the rest of them are all different. So 6x squared minus 9x squared is negative 3x squared. I don't have any other x terms. And then 2xy minus 12xy is minus 10xy. Don't have any other y terms, so minus 4y plus 4, and then minus 4y squared. Okay? It's a bit of a lengthy process. Okay, so I think we'll stop there for today. I do want you guys to try these two over here. Okay, so give these two a try. Before I do that, though, firstly, let me turn off this recording.